Here we go. We got a question: count all triplets with given sum in sorted array. So you have given a sorted array and a target value. Our task is to count id, j and k valid indices such that summation is equal to target and I is less than j is less than k. So we got this array, and if we take the summation of this value and this value, we got -2, which is equal to target. Then another valid indices will be, we can take this and this value, summation is -4, so we have to add this, uh, yes, so -4 plus 2 is equal to -2, which is equal to target. And two more valid pair are there also, apart from which I've just told you. So there are um, four valid combination or four valid pairs. So we got this test case. In this, we have not find any triplet whose summation is equal to 1, so we have to return 0. Now let's build the approach. So I have taken the same test case. First, what will be the brute force? We need to find three values. So array of I plus array of j plus array of k. Is it k? Yes. So it should be equal to target. So what will be our brute force? I will be here, j will be here, k will be here. We find the summation. If it is equal to target, we have to consider this, means we have to increment our answer. Else we need to increment our k, then we will again increment our k, then we will again increment our k, then we have to increment our j, then k will increment, and k will increment. In this, the time complexity will be n cube, but we can optimize this. So let's suppose we take this value on the other side, so we got this. Now let's suppose we fix a particular value, so we fix this. So before this, let's observe, isn't this array plus j is equal to new target? Isn't this similar, exactly similar to some problem? Yes. So we can utilize map data structure here. Let's suppose we fix this value, and on the remaining sub array we can apply a to sum problem using map. So we got this value, and what will be our new target? It will be target minus our fixed value, which will be 1. Then we have this value. Our initially our map is empty, so what will be the equation in this case? So in this case, the equation will be this. We have to find this value. So our new target is 1, and our current value is -1, which we got 2, but 2 is not in our map, so uh, we cannot do anything. We need to just insert this value into our map. Then we got this value. We got same as 2, but we have not find 2, so we have to insert -1. -1 is already there, so we need to increment the frequency. Then we go to 0. So if we add 0, we got 1. Is 1 there? No, 1 is not there. Just add your value, and we have added 0 with frequency 1. Next we go to this, so it will be 1. We go to 0. Is 0 there? Yes, 0 is there only once. So it means if we take these three values, we got summation as -2. You can verify it. So I will not gonna code this particular algorithm, this particular approach, but because there's a scope of improvement. So before that, let's talk about time and space complexity. In this case, the time complexity will be n square. So because we have fixed a particular value, and the remaining problem will become exactly similar to 2 sum, and in 2 sum the time complexity is order of n. So the total times complexity is order of n square, and space complexity is order of n. So we have talked till now, but we can avoid the space complexity. Let me erase this. I mean, we can improve it to order of 1. We can do this question in constant space, because the given array is already sorted, so we can utilize this. So let's suppose we fix this particular value. We need to find ith value, a of I plus a of j plus a of k equal to target value. So I will took this value on the other side, and we got this, means we got our new target. So the remaining problem is this: as we got our new target, it means we have fixed a particular value. So we have fixed this particular value, and the problem is exactly similar to sum. As our array is already sorted, so we can apply two pointer approach, because we have to find two values and the pair of two values which is equal to the target. So now let's do this. What is the new target? New target, new target. What's the new target? It means target minus fixed value. What is this? Minus 2 and minus 1. We got, yeah, we got, no, it is not minus 1, it is minus 3, I think. Yeah, we got minus 3. So the total is plus 3, we got 1. So we need to find 1. Or, in other words, we can do a simpler method. We can solve it in simpler way, means we have fixed a particular value, plus on the remaining subarray, we have L on just the next index and R pointing to the last index. So we need to find L plus R is equal to target. But this isn't enough. I will tell you why. Actually, we got minus 3 and we got minus 1, then we got 2. We need to make it equal to minus 2, but what we got? Minus 4 plus 2 is equal to minus 2, means 2 is equal to minus 2. The value is greater. We need to take smaller value. So we can either increment I or decrement R. So we want to take the smaller value, so what we will do? We will decrement our rth value. Now what's the case? 1 1, so we got 1, then we got minus 3. The value is much smaller. We want to take bigger value, so we will increment our L. We got same value. The value is still minus 3, which is less than, minus 2. We want to take bigger value, so we will take this value. So we got this pair. Yeah, we got this pair. So we got 0. Now let's find the new summation here. So we got 0 and then we got minus 2, which is equal to the target value. It means this is a pair, but this is a pair, so we have to increment increment our I, increment our answer obviously. Then let's increment our L and decrement our R. We have to increment our L and decrement our R both. Why? So let's take a test case. Let me think about a test case. So let's consider this test case. Let's suppose we have fixed this value and we got -3. Then L is here, R is here. We got -2 plus 3. What we got? We got -2, which is equal to the target value. It means first pair is this. Then we need to increment our L and increment our L and decrement our R. So what we got? We got summation as this and this value. So it will be -3 -1 plus 2. Then it will be -4 plus 2, which is equal to -2. So this is also a valid answer. Means if we have found a valid answer, so then we are we need to find another valid answer. So this is a valid combination and L and R is on a valid values. So on one side, if I am incrementing a value and on the other side I am decrementing a value, so there may be a another combination, but this is not enough. Why? So let's take a different test case. So let's suppose I have fixed this particular value and my L is here, R is here. We got -3 plus 0 plus 1. We got -2, which is equal to -2. We got our answer. Our answer will be instead of 0, we got 1. So if I directly increment our L and decrement our R, then what we got? We got -3. Then it is less. It means we have to increment our L. As we reach the same value, so we are outside our while loop. But there are 3 different valid answers, but we only found one. How? First of all, this and this particular value. So the summation is -2, as you can clearly see. Then another valid combination will be this, as you can clearly see. The answer is -2. The summation is -2, and another answer will be this. The summation is -2. So we got 3 different values. So our approach is kind of correct, but we are missing some valid values. So now we have to do something. So let's suppose we have fixed this particular value. My L is here, R is here. I have first of all I need to increment this value. Now I am in search of another valid values. Another valid values. So let's suppose we got this, and these three values is equal to the starting value itself. So we need to find till when we are getting the same value. So let's take another variable. So this is I variable, this is L variable, this is R variable. So I am taking start, and start is L plus 1. Start is pointing to L plus 1. If start is equal to the previous value, means this is also a valid combination. You can check it. Yes, this is also a valid combination. If our start is equal to the previous value, increment your answer, and on the next step also increment your start. Also increment your start. Is start equal to the previous value? Yes. So this is also a valid combination, as you can check. Yes. So increment your answer. Start will again increment. Then at this point start will stop, because start is reached rth value. Start reached rth value, so we're gonna stop here. We have to do the same process uh, on um, on here, means we have to do the same process while checking L. So let me extend the test case. So I have extended the test case. So my started from here, then it is equal to the previous value. My start will reach here, also equal. Start will reach here, also not equal. So start should stop here. Then we have to do the same process on the end, on the right hand side. So I have another variable name and. So and is r minus 1, and is r minus 1. Is and equal to the next value? Yes. So this is also a valid combination. You can check. It means this value and this value will be a valid answer. Then and will decrement. Is it equal to, is it equal? Yes. So again increment your answer. Is and equal? Yes. Increment your answer. Is and equal? No. Now it is not equal. Then what are we gonna do? So till now, till now I have just checked the valid combination. If I fix my r and my ending is changing, or another way to view this as I have fixed my r and changing the starting positions. So we got 6 valid pairs. So we pair up with this and this value. So we got 4. Then um, we got 3 more. So 4 and 3 is 7. So I think I have missed the value, but I think you overall get the point. So I have checked all the values. Then what's the next step? The next step is to just increment your L and decrement your R. L and R will increment some values and decrement some values, and overall we got the same target. Then let's talk about the time and space complexity. So we have fixed our L I, and I will increment to the next value and the next value. Let me draw it more clearly. So let's suppose my L reached this point, and on the remaining array, actually my I reached here, and on the remaining array I am applying 2-pointer approach. So you can visualize it. I tried my best to draw. So now let's talk about the time and space complexity. So I is changing, so it will take order of n, and on the remaining array we have 2-pointer, so 2-pointer will also take order of n, so it will be n square, and space is constant. Now let's code this. Code is very simple. So we have answer and n, we have a simple I pointer L and R. While this condition holds, take the value. If value is equal to target, this is the crucial point. Consider this combination. Then start will increment and end will decrement. First we are starting on the left hand side. So we are checking on the left hand side. If the current value equal to the previous value, consider answer and jump to the next value. Then I am changing on the right hand side. So if my ending so I have decremented, so I am on a one less index. So if my ending is equal to the next value, consider this combination also and go to the previous index. So we got some indexes. It's time to find uh, with different indices. So L and R will change. Else if our value is less, we need to increment the value. If our value is more, we need to decrement the value. Overall, we need to just return the answer. Let's submit this. So I've already discussed about the time and space complexity. So it should work. The code is given in the description box, and we have solved this question. Thank you all for watching this video.